class. Today our topic is on reviewing trigonometry of right-angled triangles. First thing, we need to know how triangles are labeled. So in a right-angled triangle, or in general triangles, we always use capital letters to represent angles, and we use little letters to represent the corresponding side. So when I say corresponding, I mean the side that is across from the angle. The hypotenuse is also the longest side in a right-angled triangle, and the longest side is always the one that's across from the 90-degree angle. So in this case, it says that angle B is our 90 degrees. So I'm going to label this. This is capital B, and the side that corresponds with it is the one across from it. Our hypotenuse is represented by little b. Now, if it doesn't indicate where A and C are, then it doesn't really matter as long as we line it up with each other. So this could be angle A, and over here, this would be little a. This is angle C, and this is side little c. Now let's recall Pythagorean relation. Pythagorean relation is used to find a third side if you have two sides. So the relation that we have, a squared plus b squared is equal to c squared. C is always the hypotenuse. So in this case, our hypotenuse is represented by the little letter u. So let's substitute the values that we have here. A and B are any sides that touch the 90-degree angle. So we have 8 squared plus 15 squared is equal to u squared. Let's solve it now. So we have 64 plus 225 is equal to u squared. We're going to collect our like terms. 289 is equal to u squared. And for us to undo the u squared, we need to take the square root on both sides. So square root of 289 is equal to 17. Okay, now using trigonometry ratios to solve for angles and sides, we have two more vocabulary words that we need to know. So we already talked about hypotenuse being the longest side that's across from the 90-degree angle. We also have the adjacent and opposite, and all of that is related to where the working angle is. The working angle is just defined as the angle that we're working with in order to solve. So your working angle could be any of the two angles that is not the 90 degrees. So in this case, it's told us that 90 is represented by letter D. So we have D here. Angle E is the working angle. I'll label this as E. It could very well be here, but that would just mean that our other adjacent and opposite will be relative to the angle here. Okay, and then our other one would be angle F. So this is our working angle. I'm going to circle it because everything has to be relative to this now. So our opposite is the side that is across or opposite from our working angle. Let's write our definition here. The side across or opposite to the working angle. And finally, we have our adjacent. And the adjacent is the side that is remaining, but also the side that is between our working angle and the 90 degrees. Now, let's say that we had labeled this as angle E. That's fine. We just have to label it accordingly. So if this was angle E and our working angle, then this side would now be our opposite because this is across the way from the working angle, and these two um, angles give us the adjacent in between. Now, our primary trig ratios, you probably remember the memory trick, SOHCAHTOA. It represents that we have sine of our angle is equal to opposite over hypotenuse. Cosine of an angle is equal to adjacent over hypotenuse. And tangent of an angle is equal to opposite over adjacent. Let's do a couple of examples to refresh our memories with these trig ratios. Right, the first thing we need to do is we need to identify the sides that we have before we can figure out which trig ratio to use. Now, since we're given this as our angle, I'm going to say this is my working angle, and I will start labeling things relative to this. So x is our opposite, and 7 centimeters is going to be our hypotenuse. Now, when I check back at my menu to see which trig ratio involves opposite and hypotenuse, I see that sine has opposite and hypotenuse. Okay, so we're going to use our sine ratio. Sine 35 is equal to opposite over hypotenuse. Now, instead of solving for sine, I would like us to solve it right at the end so that we don't um, have to round as many times. So let's take this, we're going to cross multiply, and we have 7 sine 35 is equal to x. Okay, let's go to our calculator here. Make sure that you are using degrees because a lot of times it is by default set on radians. Nothing wrong with radians, it's just a different measuring unit. And right now in this course, we're going to be using degrees as our unit for measuring angles. Okay, so we have 7 times sine 35. Okay, so the side that we have is 4.01. Let's round it to one decimal spot. So we have x is equal to 4.0 centimeters. Okay, let's look at our second example here. We have triangle MNO. We need to find side x. We are given the working angle of 53 degrees. Well, first of all, I know that x in this case is our hypotenuse. And since this is my working angle, 12 meters is going to be our adjacent. This is the side that's in between our two angles. All right, the only ratio that involves adjacent and hypotenuse would be our cosine. So we have cosine is equal to adjacent over hypotenuse. So let's substitute it in for what we know. Cosine 30 or 53 is equal to 12 over x. And we're going to cross multiply again. So we have x times cosine 53 is equal to 12. I'm going to divide both sides now by cosine 53. So we have x is equal to 12 divided by cosine 53. And we have 19.939 and a bunch of other decimal spots. Let's round our angles to the nearest angle. So we would get 20 degrees for our x. Okay, we can use primary trig ratios to solve for angles as well. Let's do the same thing. We're going to use this as our working angle. So let's identify the information that we have. 12 is our hypotenuse, and 7 is our adjacent. The hypotenuse and adjacent, we're going to be using cosine again. Okay, cosine of theta. Theta is a very common variable that we use for solving angles. So in Desmos, you can type in the word theta, T-H-E-T-A, and you'll get the theta symbol, is equal to adjacent over hypotenuse. Now, for us to undo this cos, we need to go to our calculator and we need to take the inverse. So go to the function and we have cos negative 1. That's what it means to take the inverse. Okay, so when you type it, you're going to have theta is equal to cos inverse of 7 over 12. And we have theta is equal to 54 degrees. Let's do another question where we need to solve for an angle. So this is our working angle. We have the side that's across from it, so that's our opposite, and the side in between our 90-degree and our working angle. We have our adjacent. Okay, this one we're going to use tangent because it involves the opposite and the adjacent. So tan theta is equal to opposite 8 over adjacent 9. So let's undo tan now by taking the inverse. So I have inverse tan of 8 over 9. So once again, our scientific calculator is going to do all the work. Find your inverse tan key, which is in the function, and then 8 over 9. That gives us an angle of 41.6. Let's round it to a whole degree, so 42 degrees. Okay, sometimes we're asked to solve for a triangle. The word solve means to find all the sides and find all the angles. So in this case, we've already been given the three sides. We know that 90 degrees is our C. So we can label this little c and A and B could be any of these ones. Now, since we don't have a working angle, you are going to determine the working angle now. You can choose to work with B or you can choose to work with A. Once again, as long as you identify your adjacent and opposite relative to your working angle, then it doesn't matter which one. You will still get to the same answer. Now, for me, I'm going to pick A as my working angle. So if I picked A as my working angle, I'm going to have 12 as my opposite, and 9 is going to be my adjacent. 15 is going to be the hypotenuse, regardless of whether I'm using A or B. So, because I've been given all three, I could choose any of the ratios to solve for angle A. So, adjacent and opposite, I'll use those, and that would mean that I need to involve the tangent ratio. So tan A is equal to opposite over adjacent. Let's undo our tangent now. So A is equal to inverse tan of 12 over 9. So inverse tan, 12 over 9. We have 53.13. Let's round it to the nearest degree. So A is 53 degrees. Now to find angle B, I could go through and use a trig ratio as well, but I also know that a triangle always adds to 180 degrees. So since I know that, I could use that to go backwards. So let me just note this. All triangles add to 180 degrees. So that means if I took angle A plus angle B plus angle C, this has to equal 190. We know what angle A is, we know what angle C is. So that means we need to find the difference and we'll know what B is. Right, 53 plus b plus 90 degrees is equal to 180. So b is equal to 180 minus 53 minus 90. Let's go back to our main calculator. 180 minus 53 minus 90. We now have b is equal to 37 degrees. Okay, here's another question where we're asked to solve the triangle. We're going to draw triangle PQR. Angle Q is 90 degrees. Little r is 9 meters and little q is 14 meters. Solve the triangle. Find all angles and sides. Right, let's draw our triangle. Here's our 90 degrees. And they've told us that we're using the letter Q to represent the 90-degree angle. Okay, little q is the side that's across from there. This is 14 centimeters. Now, I also know that this is our hypotenuse. We also have side P and side R. So let's just label them. Capital P, this is now little p, and then capital R and little r. Now they've told us little r is 9 meters. Okay, so to solve for all the sides and angles, I will first need to find an angle that I want to work with. So let me work with angle R. So if this is angle R, this is still my hypotenuse, and this would be my opposite. Opposite and hypotenuse, that would be a sine ratio. So sine R is equal to opposite 9 over 14. Now let's undo our angle R. R is equal to inverse sine of 9 over 14. So inverse sine 9 over 14. That gives us an R of 40 degrees. Okay, since we know that this will add up to 180, I could say that angle P is equal to 180 minus 90 minus 40. And so we have P is equal to 50 degrees. Now our last side is P. We could either use Pythagorean relation or we could use a trig ratio to solve. It doesn't matter which one. It all depends on what you prefer. Now, I know a lot of people feel more comfortable with Pythagorean relation, so let's use that one. So we have p squared plus 9 squared is equal to 14 squared. P squared plus 81 is equal to 14 squared, 196. P squared is equal to 196 minus 81. P squared is equal to 115. And we're going to undo the P by taking the square root. $10.7. P is equal to 10.7 centimeters. Now, if you chose to do it using a trig ratio, that would be fine as well. You would get to the same answer. Okay, I would like you to try this on your own. Pause the video, do this question, and then we'll come back to it in a bit. Right, so I'm assuming that you've done the question. Let's take this one up. For us to find side x, we have to use trig ratios because we only have one side given. We can't use Pythagorean relation. Now let's label our sides so that we can see which ratio to use. X is our opposite, and the 9 here is our adjacent. So TOA, or the tangent ratio, involves both the opposite and the adjacent. So let's use that to solve. Tangent 40 is equal to opposite over adjacent. 9 times tan 40 is equal to x. So we have x is equal to 7.6 millimeters. Okay, there are 5 practice questions now. Please go work on those, and then the next part of the video will include some problem solving.